Hi students, welcome back. Today we are going to look at k closest points to origin problem. This is a very classical problem called the kth problem. Let's look at the problem statement first. So the problem statement says we are given an array of points. A point is represented by x and y coordinates. We have to return the kth closest point to the origin. Okay. So k is also an input and we are given an array of points. We have to return k number of points closer to the origin. How do you define closer? Closer is nothing but based on the distance from origin, and distance between 2 points is nothing but square root of x1 minus x2 whole square plus y1 minus y2 whole square. But in our case x2 is always 0. So this would essentially be square root of x1 square plus y1 square. Okay. And again, since we will only be doing comparison, we need not even do square root actually. We can just do x square plus y square because uh, in comparison, square root will not have any value. Okay. And it says you may return the answer in any order. We need not worry about the order to sort the answer and all. We just have to return kth closest points to origin. It need not be that the smallest point, closest point is the first one, etc. Okay, so let's look at some examples. The first example is this is the graph we are given. These are the 2 points 1 comma 3 and minus 2 comma 2. Okay, the distance between 1 comma 3 and origin is square root of 3 square plus 1 square, which is square root of 10. And for 2 comma minus 2, it's square root of 8. So square root of 8 is smaller than square root of 10, which is why this is the closest point. Okay, and in the given problem k is 1, which is why we will just return minus 2 comma 2. Now if we look at another example, here we are given 3 points. Okay, 3 comma 3, 5 comma minus 1 and minus 2 comma 4. Okay, here the closest 2 points are minus 2 comma 4 and 3 comma 3. Okay, for 3 comma 3, the distance is 9 square plus 9 square, 18 square root. For minus 2 comma 4, it's 4 square 16 plus 2 square, which is square root of 20. And for 5 comma minus 1, it's square root of 5 square plus 1, which is square root of 26. So these two are closest and we can return them in any order. 3 comma 3 minus 2 comma 4, minus 2 comma 4, 3 comma 3. Both are valid answers. Okay. So let's look at the solution of this. So if you think of it intuitively, what we can do is we can just sort the input array by their distances. Okay. And while sorting, we need not consider square root, just the actual values, squares of the numbers is enough. Because in comparison with square root, it won't change anything. Okay. So we can sort the numbers based on the squares, sum of their squares, and we can return the top k elements. That is one answer. Okay. So the first method is sort all. Okay. And for sorting all, it would be order of, in the best case, sort can have order of n log n. Okay. That will be the time complexity for that. The second implementation, what we can do is instead of sorting all the elements, we only want k closest elements. So we only need k elements. What we can do is we can maintain a heap of size k. Okay. In this heap, once it reaches the size of k plus 1, we can remove the maximum element, which is why this should be a max heap. So we will take a max heap of size k and we'll keep adding elements to this heap. Once our heap reaches the size of k plus 1, we will remove one element, which is the maximum of it, because it won't be an answer anymore. Okay. So this time complexity would be order of n, because we process every element, and adding element to the heap would be log k. Okay. Order of n log k. So we optimize from order of n log n to order of n log k. Then there is third approach, which is based on quick sort, which is called quick select. Here what we will do is similar to quick sort, we will partition the array based on an element. So we will have a partition, we will have left side of the array and we will have right side of the array. This is greater than partition, this is less than partition. So here the condition would be if k is equal to partition's index, that means this is our answer, this side of the array. Whereas if partition is less than k, okay, if the partition is less than k, then that means um, that means our answer, we have found few smaller elements, but that is not enough. So then we have to move to the right side of the k. Okay. So if partition is less than k, we have to move to right of the array, which means we have to run another iteration on partition pivot element plus 1 comma the last element. Okay. Similarly, if partition is greater than k, then that means every element on the right side is greater, so those are of no use for us, so we can exclude that and we will run our new iteration on low to that partition number -1. So this is how quick select works. So in the array we will partition it based on a pivot, and if pivot is equal to k, that means we found the answer. Every element left of the k is the answer. Okay. Whereas if pivot is less than k, that means we found few elements but they are not enough. So we have to run the same thing on the right side of the array. If pivot is greater than k, that means every element on the right of the pivot is of no use to us. So we will run it on the left side of the array. So this algorithm takes order of n complexity in best case and average case, whereas in worst case it will still be order of n square. But still this is one of the best selection algorithms we got. Okay. How is it order of n complexity? That is because every time we are what is it called, we are reducing the number of elements that we process to half. Whereas in quick sort, what we do is we have to process both sides of the pivot. Here we take a decision and move only to one side of the array, which is why it would be order of n complexity. Okay. Now let's look at coding for all these three approaches. Okay. So first, let's look at the simplest one, which is sorting, based on sorting. So simply what we have to do is we have to sort the array first. Okay, arrays dot sort points. Okay, and we have to pass a comparator to it. So the default sort won't work. Let's say there are 2 points p1 and p2. Okay, our comparison is based on the distance algorithm, which is x square plus y square, right? So we are sorting two numbers. So we want them in descending order. So P1 is less than P2. That's what we want. So P1 of 0 into P1 of 0. This will give us P x square of P1. Okay. Plus uh, P1 of 1 into P1 of 1. Okay. P1 of 1 into P1 of 1. Okay. This is P1's distance minus P2's distance, which is P2 of 0 into P2 of 0 minus P2 of 1 into P2 of 1. Okay. This should give us a comparison points. Okay. Once we have the sorted array based on this, we have to just return the first k elements of this array. Arrays has a helper function called copy of range, which will give us the elements within that range. So we want from 0 to k. Okay. So this is the simplest and clean solution with order of n log n time complexity. Okay. So we are just sorting it and then we are returning the first k elements. Okay. So the solution is accepted. Now let's modify this to implement a priority queue. Okay. First let's define a priority queue. Okay, so priority queue is of type integer array because we have 2 points, right? PQ priority queue is equal to new priority queue. So this will be a max heap. Okay, and for the priority queue, what is the priority condition? Okay, priority condition is nothing but similar to our comparator P1 comma P2. Okay, similar to our comparator. Okay, now we could even copy this. Okay, so here we are doing a less than b, so this will give us min heap, but what we want is max heap, which is why we have to reverse the signs. Okay, so this will give us max heap based on the distances. So the highest distance would be given out first when we delete an element from the queue. So now when we add elements to the queue for each element, okay, for each element we offer it to the queue. Okay, and if queue size is greater than k, we will remove the element. So when you offer it to the queue, it will follow this function and it will add to the queue. When you remove from the queue, it will remove the element which has the max distance because it's a max heap. Okay, now we have constructed a heap based on it and we have k elements in the heap. Now we have to uh, transform that to an array and return it. So let's define a result array. Result array is of size k and 2 because we only have 2 points. Okay. Now for size k, we keep polling from it and adding it to the result array. Okay. So poll from the priority queue and add it to a result array and return the result. Okay. So this is our priority queue implementation. We created a priority queue and defined the priority depending on the maximum distance. And as soon as the queue size reaches k, we are removing an element from the queue. Okay. Now after processing all the elements, we are just transforming that to an array and returning it. Okay. Let's submit this and see. Okay. Now let's try the quick select approach. That is a bit complex than these two. Okay. For that, first what we need is we need to define the low and high points. Okay. So initially when we are starting, low is nothing but 0 and high is end of the array. Okay. So what we will do is while low is less than or equal to high, as long as low is less than high, okay, we will find a pivot using a partition function which we will define later, very similar to quicksort. We will partition the array from low to high, and now what is our break condition? If pivot is equal to k, that means we have found the solution. We break. Okay. Otherwise, if pivot is less than k, that means we haven't found the solution yet. So what we will do, if pivot is less than k, we will move to the right side of the array. Okay. So we move low to pivot plus 1. Else, if else means pivot is greater than k. In that case, we move to left side of the array, which means we move high to pivot minus 1. Okay. So we find a pivot. If pivot is equal to k, we found the answer. If pivot is less than k, we move to the right side of the array. If pivot is greater than k, we move to the left side of the pivot. Okay. And once we find it, we return the first k elements of the array similar to our old approach. Okay, so this is the process. Now we have to define the partition function. So how do we partition the array? Okay, so our partition function takes a points, its low and high into consideration. First, in partitioning, we have to define a pivot. Okay, so pivot can be a random select, or you can pick the first element or last element. So for simplicity, I am just taking the high as the pivot. Okay, initially when we start, I am taking two elements I and j at low. Okay, so j will actually, what it will do is, it will traverse through the array. It will keep searching for elements which are less than pivot, and it will move them to the left of I. So I and j will point to the start and end of the right side of the array. Okay, right side of pivot. So what I will do is, for j equal to low, j less than high, j plus plus. Okay, I will do a comparison of the current point with pivot. Okay, if it is greater than pivot, I don't have to do anything. If it is less than pivot, I have to swap it with I. Okay, so that I to j, I always have elements which are greater than pivot. Less than I, I'll have elements which are less than pivot. Okay, so now if I compare it, then I'll have to swap the elements. Okay, once I do a swap, I have to do I plus plus also. Okay, so this is the operation we have to do. Now once we reach, like we said, I and j point to the starting index and ending index of the right side of the pivot. So we have to swap pivot with um, the right side of the array. So our pivot is the last index, which is high, right? So we have to swap the I with pivot, so that pivot would be at its right position. So after this operation, what we have essentially done is, we have found the correct position for the pivot element. So if we do a swap, then pivot will be at the ith position and I will be our pivot index. Okay, we have to return I. Okay, so what we are doing is, we have taken two pointers I and j. I and j point to, I points to the first element to the right of the pivot, j points to the first element to the last element to the right of pivot. So to start with, both are at 0. Okay, so we keep comparing that point with pivot. If it is less, that means we have to push it to the back. So if it is less, we swap it with I and increment I. If it is greater, there is nothing to do. We just advance I. And once we reach, we have I and j, we have pivot, and we have some elements towards the left of I. So to insert pivot in the right position, we swap ith element with pivot element. Okay. So in this process, we have used two functions. One is compare and one is swap. Swap is pretty simple. Okay, given two elements, you just swap it. You just take a temporary element and swap it with I and j. Similarly, compare is nothing but whatever we have done with arrays.sort comparator. Okay, we just return x square plus y square, x1 square plus y1 square minus x2 square minus y2 square. Okay, so this completes our implementation. So we have taken low and high. As long as low is less than high, we find a partition in the low to high range. If partition is equal to k, that means we have found our answer. Otherwise, if it is less than k, we move to the right of the pivot. If it is greater than k, we move to the left of the pivot. And how do we find? In a partition, we have to take a pivot element first. We can pick it in any order. There are so many algorithms to pick this pivot element. I've just chosen the simplest of picking the last element. And I move from, I take two pointers I and j, and I traverse throughout the array, pushing all the elements which are greater than pivot to the end. And I, at the end of it, I will be at the first largest element of the pivot. So I swap it with I and I return the pivot index. Okay, let's run this and see. Okay, let's submit this. Yeah. So we have seen three approaches to solving this problem. Time complexity wise, this quick select, though a bit complex, is the best one to use. This one will be, this quick select is also very helpful in other problems called the kth largest elements and similar problems. Okay. As always, keep practicing and improving your problem solving skills. If you have any queries, do leave a comment. Please like, share and subscribe. Thank you. Happy coding.